Good morning, student. And today we are going to discuss the some numerical which are already asked in previous year's paper. And today we are discuss only the numerical, and this numerical is in the session 18-19. और आई थिंक सो अगर आप पेपर्स को अगर आप देखेंगे तो ये पेपर आप 18-19 के सेक्शन ए में दैट इज आई थिंक सो इन जे पार्ट का आपका ये न्यूमेरिकल है जो डिस्कस किया जा रहा है. Now, the what first of all I'm going to explain what is the numerical. Given that 5, 4 even parity block code, find the corresponding to I1. ये आपका message bit है and I2 in for message second bit है, and what will be the code vector. Okay, अगर हम थोड़ा brief करें about the linear block code, we know the linear block code represented by comma n comma k, n comma k. Here k is the message bit and n is the number of encoded bit. Means if we add the some extra bit or encoded bit to the message bit, then finally we get the encoded bit which is of the order of the n. Here also as we know that is a single parity check code. In this a single check bit are added to the message bit, and finally we get the message bit means which is transmitted through the channel. Now the 5, 4 means here the message bit of the 4 bit and the encoded bit of the 5, means there is the difference of these two 5 and 4 we get 1, means here the 1 bit is added to the 1 bit added to the message bit, and finally we get the encoded bit of the 5 bits. Okay, here the message I1 is equal to 100, and already मैंने ये न्यूमेरिकल को मैंने सॉल्व किया हुआ है. that is I1 is equal to 10. Single parity means here we add the single bit to the message bit, this message bit of the 4 bit, and after adding the 1 bit and 1 bit, maybe the 1 and 0 depend upon which parity are used. And here already told that is even parity, means here we have to take the even parity. Even parity means the number after the coding, after the addition of the message check bits to the message bit, and finally we get the number of ones in even. Okay, if it can ask in the odd parity, the number of ones will be the odd. But in already numerical asks that number of bits are even, that is the number of ones in total message is equal to the even. Okay, now the first message is a 1011, and we have to add the single bit, and if we count the number of ones in this message, first message, and that is the 3. Now here we have to make this number to the even, means the next even will be the 4 bit 4 number of ones. Then here we add the extra bit, and that is of the 1 bit, and which is the value is equal to 1, and finally we get the message and 10111. And if we count the number of ones in this encoded message, and here will be the 4 means the number of ones will be the even. Now this is the message which of the 4 bit, and after encoding it converted into the 5 bit, means if we compare with this one, means the message encoded bit of the 5 and message bit of the 4 bit. Okay, this is the first answer. After that the second message, that is 10 and 10, means if we count the number of ones in this message equal to already even, means 2, and no need to change its number of ones. And if we place, means what should be the value of here, means 0. If we place a 0, because in binary there are two numbers which are used, that is 1 and 0. If we place 0 here, means the fifth bit, then the overall the number of ones can't be changed, means already it is even. And finally we get the encoded message like this, and that is the 10100. So this is the solution of the first question, which belongs to section A and J part in the session 18-19. Now the next numerical, that is section B, and I think so question number 2 का आपका I think ये A part होगा. And what should be the question for a systematic block code, that is 6,3, and block code here the already given the parity matrix, that is P, ये matrix given है. and detect and correct the single error that occurred due to the noise and draw its syndrome calculation circuit. So what is the already numerical arcs means already we know that is about the Hamming code or systematic code in which a single error can be detected and corrected. Now here already the parity matrix are given. Now here we take the example and we show what's the procedure to detect and correct the single error and due to the noise, and also according to the given p, and we have to calculate the syndrome circuit, means what will be the output can be calculated by using the circuit. Okay, now for the systematic code, that is solution part, अगर हम बात करें solution for systematic code, that is 6,3, and first of all we have to calculate the n, k, q. These are the three parameter. N means here already on comparing we get 6, and this is the message bit of k is equal to 3, and finally a q, that is check bit, number of the check bits is equal to 6 minus 3, that is n minus k, and here we get 3. तो on comparing मैंने already वो discuss किया हुआ है. On comparing here we get these values like written like this, that is n is equal to 6 and k is equal to 3 and q is equal to 3, and what will be the parity matrix, that is the H. That's a parity check matrix. The other confusion, that is the parity matrix P, and this is the parity check matrix, and which written like this, and ये already standard format में है, and this is the P, and this is the square matrix, and which of the order of the Q cross K. This is the I think so Q cross Q, and this is the Q cross K, and finally we get Q cross N की matrix आपकी होती है. Okay, so finally by using the parity matrix and by using the identity matrix, and we get the H, and H is called the parity check matrix. And now we know that first of all in the syndrome decoding, the first option we have to calculate the S, and already written in the form of the capital X, and we have to calculate the S calculated by y s to the power t, means that is y into h transpose of parity check matrix. This is the formula already, and we have to calculate by using this formula. Now I am assuming a single received vector written like this, that is 100 and 100. Now in the process by using that is here s is also of the check bits, means that is q. Here we can say this q indicate this one. Okay, means s is of the 3 bit, and after that we know here y into h to the power t, and already y written जो हमने assume किया हुआ है, हमने इसको assume कर लिया. ये आप इसके अलावा कोई भी आप assume कर सकते हैं, ठीक है, इसमें कोई बहुत issue नहीं है. And after that this is the matrix H. Now here we take the transpose of matrix transpose. How it can transpose can be find, simply convert the row into the column and column into the row, we get this matrix. And after multiplying तो मैं already asked, मैं बोल चुका हूँ कि before multiplying first of all we have to check the column of the first matrix and row of column of the first matrix and the row of second matrix. If we here we can see here the matrix is order of the 1 cross 6, and here the matrix is order of the 6 cross 3, and finally here we get the matrix of the 1 cross 3, and already we get this one. Okay, now simply multiplication of this one, then this one, then this one, then this, and after that, and simply after multiplying the values, and finally we get the single, means after multiplication of all the processes there is the modulo sign between the two's multiplication, means simply here we check if the number of ones that is odd, then value it's 1, if the even, then value is equal to 0. So by using correspondingly if we multiply by using this one, means this overall value multiply with this column, and we get the value 0. That is the first bit of the syndrome. Then if we multiply again this column, and then again we get 0, and if we multiply this with this column, and then we get 1. Okay, means here we get s is equal to 0 0 1. ओके, तो हमने जो यहाँ पे जो हमने यहाँ पे जो हमने रिसीव वेक्टर सेलेक्ट किया हुआ है, तो अब ये नहीं है कि आपको हमेशा आप अपने अकॉर्डिंग कोई भी आप रिसीव वेक्टर ले सकते हैं, तो करस्पॉन्डिंगली उसके अकॉर्डिंग ये आपका एस चेंज हो सकता है. ओके, now what next we have to do, and then after getting the s we have to compare with the rows of the s transpose matrix, and if we see this match with the sixth column, six rows of the sixth row of the matrix, means already discussed, there are the six row, and the error pattern जो होता है वो भी 6 bit का होगा, that is e is equal to e1 e2 e3 e4 and e5 and e6. तो जिस रो से आपका s की वैल्यू मैच करेगा उसके अकॉर्डिंग उस बिट्स पे हमारा एरर होगा. ठीक है, तो आप देखें यहाँ पे जो लास्ट रो से मैच कर रहा है, दिस इज द सिक्स रो, मींस देयर इज द एरर एट द लास्ट बिट, दैट इज 6 बिट. So according to we observed that the syndrome s is equal to 001 correspond to the error pattern, that is e is equal to 000001. मीन्स जिस नंबर पे आपका जिस रो से मैच कर रहा वो नंबर अकॉर्डिंग आप उस प्लेस पे एरर पैटर्न का 1 को प्लेस कर दोगे, एंड बाकी ऑल द रिमेनिंग टर्म्स आर जीरोस. then this show that there is error in the first received bit, सॉरी 6 received bit, सॉरी हमने ऑलरेडी यहाँ पे ये आपका दिस इज द 6 होगा, ये जो आपका कंप्लीट है, जो दिस वन दिस इज द 6, दिस इज 6, इसको हम 6 बोलेंगे. Okay, this is the 6, and after to get the value, and here we simply take the received vector and XOR operation with the error pattern, and we get this is the received vector already जो हमने assume किया था, and here is the error pattern, and finally we get the value this one. ठीक है, this is the actual value transmitted from the transmitter. Okay, this is the first case, and again if we take the y is equal to, अगर आप ये अगर चूज करते हैं आप लेते हैं, and similarly if we calculate the value of s and by using this formula, and then we get, means if the all the bits of the s is equal to 0, means there is a no error in the received vector, means जो received vector है वो transmitted vectors आपका match कर रहा है, there is a no error. तो ये आपने देखा किस तरीके से आपने सिंगल बिट्स को आप यहाँ पे यूज करके आप सिंगल बिट को अपडेटेड और आप इसमें करेक्ट कर सकते हो. नाउ the next part, the syndrome vector is 0, there are no error in the received vector. Okay, now syndrome calculation circuit. So first of all we have to assume error vector that is already discussed by using the, that is each of 6 bit, that is e1 e2 e3 e4 and e5 and e6, and syndrome of 3 bit already discussed, that is the check bit s1 s2 and s3. Okay, one more formula for getting the syndrome, that is s is equal to e that is e into h transpose. This is the one more formula to calculate the syndrome if the error patterns are already given. Then simply here we place the error pattern of the 6 bit that is represented by the matrix in the form of the 1 cross 6, and the matrix S transpose is of the 6 cross 3 matrix, and simply again here we have to multiply, and on solving and on comparing, and we get s1 is equal to e1 XOR e3 XOR e4, and x2 is equal to e2 XOR e3 XOR e5, and s3 is equal to e1 XOR e2 XOR plus e3 XOR plus e6, and this is, and then here we take error, and using the 6 blocks to indicate the bits by bits error, that is e1 e2 e3 e4 e5 e6, and there is the 3 modulator which are used, because here there are the 3 syndrome consist of the 3 bit, means 3 modulator which are used printed by s1 s2 and s3, and like the first s1 is the modulo operation of the 3, दैट इज E1 हमने ले लिया है, फिर हमने ये E3 ले लिया, आपको दिख रहा होगा, फिर अगेन वी टेक द E4, ऑलरेडी वी टेक द E4, एंड देन फॉर द x2 दैट इज E2, ऑलरेडी E2 हो गया आपका, ये E3 हो गया, एंड E5, एंड वी गेट x2, एंड x3 के लिए आपने देखा होगा आपने, दैट इज E1 हो गया, E2 हो गया एंड E3 हो गया एंड E6। इस तरीके से आप यहाँ पे सिंड्रोम का सर्किट आप बना सकते हैं। जैसे आपने याद होगा, जैसे आप लोग हेमिंग कोड में जो इनकोडर का सर्किट बनाते हैं, सिमिलरली इनकोडर के सर्किट्स में होता क्या था, आप वहाँ पे जो चेक बिट्स फाइंड करते थे, दैट इज इन टर्म ऑफ द इनपुट मैसेज, दैट इज M1 एंड M2, इस तरीके से फाइंड करते हैं। सिमिलरली हियर एरर्स के अकॉर्डिंग आप सिंड्रोम को फाइंड करेंगे। तो दिस इज द कंप्लीट सोल्यूशन ऑफ दिस न्यूमेरिकल। किस तरीके से आपने जो पहला पार्ट था, डिटेक्ट एंड करेक्ट द सिंगल एरर that occur due to the noise and then calculate its syndrome calculation circuit. Now the next numerical, that is the find the binary and ternary Huffman code for random variable x with the probability is already given. There are 6 random variables having the 6 probability, and also calculate the expected length is already formula given a summation pi li. And after that, I've already discussed the Huffman codes, each of the 3 types, that is the binary, ternary and quaternary. And here 2 types are asked, and we have to calculate, we know the what should be the procedure algorithm already discussed। मैं सीधे numerical पे मैं discuss करता हूँ। तो as we know, for the first column is of symbol, तो मैंने यहाँ पे symbols assume कर लिया according to the probability, means that is 1/21 आपका हो गया, x1 हो गया, next x2, x3, x4, x5, x6, means the higher probability of the, each of the x6 and its value is 6/21। Now we know the first column, in that the symbols are arranged with in decreasing order of the probabilities। Now 6/21 is the greater probability in comparison all। तो इस तरीके से आपने यहाँ पे सिंपली आपने ये सिंबल्स को अरेंज कर लिया इन डिक्रीजिंग ऑर्डर, एंड देन अकॉर्डिंग टू दैट प्रोबेबिलिटीज आल्सो आर अरेंज्ड देयर, that is 6.21, 5.21, 4.21, 3/21 and 2/1। and now what should be the procedure? First of all, we have to add this one. If you add this one, then we get 3/21, and here we place like this, यहाँ place कर दिया, and this probability shifted to this like this, okay। And after that, again add last 2 probabilities, that we get 6/6.21, and this probability goes to the top, and remaining these 3 probabilities just like shifted like this. Again add these 2 probability, we get 9/21, this is the highest probability comparison to all the probability in the next stage, that is step 4, and already 2 are shifted like this, and then again we add these 2 probability, we get 12/21, this is on the top in the stage 4, and this will shifted like this। and then after that, we know the what should be the procedure. Simply we have to place 0 1 like this, in the top place 0 and in bottom 1 in all the addition part like this, and there are the 5 stages, and after addition we get the probability addition is equal to 1, okay। and after that, what will we have to do? Simply we have to the first is that bits patterns can be formed simply by tracing the one by one uh, symbols, like that start from this one, when we move along this, यहाँ आपने move किया, and the first of all get the value sequence 1, again move like this, and then we get the correspondingly S6 की जो value आपकी होगी tracing पे 10 हो गया। Similarly, and for this one we trace like that is 0 and 0, then again this will be the 1, okay, we get 0 1। then for this that is trace values 1 आपको find हुआ, and after that value 1 1 1 1, okay, and again 1, this value is equal to 1 1 1। and after that for x3 we move like this, tracing simply 1 find हुआ and move like this 1 1 1 1, that is 0, and after that 0 again 0, means here we get 100। and after that for x2 like this 0 trace हुआ आपका, and then move like this again this 0 trace, then move like this, okay, this 0 trace, and then move like this, we get 0, means 4 times 0 which are written like this। and the last one like this one trace hua, and that's it, this 0, and after that this 0, and this will be the 0, means 1 triple 0. तो the first column is simply bits patterns हमें यहाँ मिलेगा simply by tracing, that is वो move from the stage 1 to the last stage. And what will be the actually the Huffman code, simply here swapping the tracing वाला part, tracing part means if you see 1 0 can be swapped just like the 0 1 and 0 1 1 0 and 1 1 and 1 double 0 0 0 1 and 4 times 0 just like this and this one. Okay, and what should be the length? And simply in that means this is the actual code, means this column indicated the actual code. This is the actual Huffman code which is used indicate for the correspondingly for this symbols and already for that probabilities. Now what should be the length of each code? Simply we can say that the length of any code is the how many number of bits are used to indicate that code, means here 2 2 2 3 bit 3 4 and 4. Then now calculate the, we know the formula of expected length. We have to calculate L is equal to summation PILI. Simply that is the formula L. The first probability 6.21 length 2 हो गया, 5.21 into 2 हो गया, then 4/21 into 2, then 3/21 into 3, then 2/21 into 4, and 1/21 into the 4. Simply by using the calculator and by solving, and finally we get 2.424. This is the expected length in the Huffman binary coding. One more question asked here, that is what should be the efficiency. Now again we have to calculate the entropy, and by using the formula summation x is equal to I, that is the 1 to n, that is px into log 1 upon px to the base 2, and finally we get the aspect efficiency is equal to h upon l. But in this numerical simply asks the expected length. Okay, so now in Huffman binary here we can see that the expected length will be the 2.42. Now the next ternary code, what should be the ternary code? Again the same process algorithm in the ternary code as such, simply arranging the symbol with the probabilities in the decreasing order. जो already आपको ये दिख रहा है, किया हुआ है, same process is there, but in the ternary, like in the binary, last two probabilities are that, but in that the last three probabilities are that. If you add these three, we get get 3 upon 2, 2 upon that, 1 upon 1, we get 6 upon, and this move to the top, and baki remaining probabilities just like move just like that, and this is stage 2, and after again the last two probability, three probability are added, and we get 15.21 move like this, and this remaining move like this. And simply in that we know in ternary cat that in the binary we are using the two number 0 and 1 to get the coding, but in the ternary code we are using the three number 0 1 2 already written like this, like in the already discussed in this part, here that is in the top 0 and 1 and 2, similarly here 0 1 and 2, and the large 0 and 1 and 2. This is the procedure, and to get the ternary code, and loud simply the first column simple tracing to get the code. Now first of all the tracing, what will be the tracing? If you move like this, move 0, then get 0, the first 0 0, then for this one that 1 and 0, and for this I think so we get 2 0. Okay, now for this 0 and 0 and 1, and for this 1 and 1 1 1, and at last for this one 2, I think this move like this, and we get 1, that is 2 1. Now what is the actual Huffman ternary code? Simply swap all the bits. Now और swapping करेंगे, now we get like this 0 0 0 0 1 0 का 0 1 हो गया, and 2 0 का 0 2 हो गया, and 0 1 का 1 0 हो गया, and 1 1 का 1 1, and 2 1 का 1 2. In that case also we have to calculate the expected length and what its value. Then we know the L is equal to formula, that is L is equal to summation pi li. Okay, probability means length, what should be the length, वो क्या होगा, इस केस में 2, इसमें भी 2 होगा, इसमें भी 2 होगा, इसमें भी 2, ओके, ऑल द लेंथ should be the 2, सारे लेंथ आपके 2 बिट्स आप 2 number of digits आप यूज करें to indicate all the code. Means simply write 6 upon 21 into 2, 5 upon 21 into 2, and 4 upon 4 into 2 upon 21, then 10, 3 into 2 upon 21, then 2 into 2 upon 21 plus 1 into 2 upon 21, and after calculation we get that is 1.98. Okay, now on comparing in that, in the previous case L is equal to 2.42 and this case and 1.98, and as we know, if on comparing in that case, that is efficiency, I think so we know the formula and efficiency, that is the formula, efficiency is equal to H upon L. एंड अगर हम कंपेयर करें तो दिस क्वांटिटी रिमेन सेम इन ऑल इन दीज टू कोड्स, वो आपके नियर अबाउट वैल्यूज आपकी चेंज हो सकती है बट रिमेन सेम. And but when we place this value decreases, means already we can say that in ternary code the efficiency of the code can be increased. ओके, तो हम कह सकते हैं कि हमारा टर्सनरी कोड बहुत इफेक्टिव होता है कि हफमैन कोड से. तो इस तरीके से, बट इन दैट न्यूमेरिकल only ask that is what should be the expected length in both the code. So this is all the complete solution of this numerical. Okay, and this is all about today topic. Okay, thank you.